The graph shows the megawatts of electricity used on one day in one city. We want to complete parts A through F. So here is the graph. You can see that the x-axis goes from 0 to 4, 8, all the way to 24, and this represents the hours. The y-axis represents the megawatts, and you can see it's going from 700 to 2500. Now the first part of this question is asking us, is this graph of a function? Now when we're looking at the graph, what we need to do is determine whether it passes the vertical line test. Okay, so let's check to see if it passes the vertical line test. So if we want to graph a vertical line, right, so does it only cross through one point every time you create a vertical line? Well, it looks like it passes the vertical line test no matter where you place a vertical line. It's not passing through one point. So therefore, we would say that this passes the vertical line test because we're looking at the graph. So the answer is yes. So let's go ahead and put that answer in. So yes, this is a function. Okay, now we need to determine what is the domain of this function. Okay, now remember, we're finding out what is the domain of this function. So remember, the domain represents all the x values on this graph. Okay, so you can see the x represent hours. It's going from 0 to 24. So since the function represents the amount of electricity used in one day, the domain is going to include the time from midnight, which is the 0 hour, to midnight the following day. Now keep in mind, when we say include, okay, that means that we're inclusive, meaning we're including 0 and we're including 24. So the domain is going from 0 all the way to 24. So in interval notation, it's going from 0 to 24. Let's go ahead and put our answer in here. So we have bracket 0, comma 24 bracket, and there is our answer. Okay, now it's saying to estimate the number of megawatts used at 5 a.m. Okay, so let's take a look at the graph. Okay, so what it's saying here is that you have 5 a.m. Now remember, the hours represents x. Okay, so that means that 5 a.m. represents the input. So 5 a.m. is the input, which is the hours, right? And then we want to find out what is the output, which is megawatts. And so we're estimating. So if this is 5 right here, this represents 5, what is the point on the graph, or what is the megawatts here? Well, the megawatts is, what, 900. So this point represents 900. So that would be 900 megawatts. Let's go ahead and put that answer in just to check. So we have 900. Let's check our answer, and there is our result. Now it says, at which hour from 0 to 24 was the most electricity used? So let's take a look at the graph. So on our graph, we need to figure out where is the maximum. So if you start from the left and you go all the way down here, and then you go all the way up here, and then at the top. So at the top here, okay, this point represents the maximum point. Okay, so you can see here that it was 2200 megawatts, and at what time was it? Okay, well, it was at the 15th, so this is 12, 13, 14, it's the 15th hour. So at which hour was the most electricity used? Well, it was the 15th hour. Let's go ahead and then put our answer here. So it was the 15th, and there is our result. Now it says at which hour from 0 to 24 was the least electricity used. So let's take a look at the graph. Now remember, we're going to figure out, this is where the graph is. This is the maximum. So where is the minimum value? Okay, well, the minimum, okay, is at the lowest point of the graph. So this is going to represent the minimum point. Okay, and you can see here the minimum has 800 megawatts. And at what hour is that? Well, that is the third hour. So it's at the third hour where you see that it's at its minimum. So let's go ahead and then put that answer in there. So we have 3. There's our result. Okay, now it says, call this function f. What is f of 12? Okay, so we want to find f of 12. So let's take a look at that. Okay, well, if we're looking for f of 12, remember that 12 represents the input, or x. So we're looking for f of 12, and that means that this is the 12th hour. And so we're looking for the megawatts. So let's take a look at the 12th hour, and then we're going to follow it all the way up to the graph. And then what is the output? Well, the output is 2,000 megawatts. So therefore, this ordered pair is 12 and then 2,000 megawatts. So therefore, it's going to equal 2,000 megawatts. Let's go ahead and put that answer in. We have 2,000, and there is our result. Now it says to interpret the answer in this context. Okay, this says this value represents the power used by all the electric consumers in the city at midnight, which is 12. And here 12 represents noon here, right? And then we said that midnight represents 0. Okay, this value represents the power used by all the electric consumers in the world at 12 noon. This value represents the power used by all electric consumers in this city before noon. And this value represents the power used by all the electric consumers in this city at 12 noon. Okay, so we need to pay attention to the question. It says in one city. So we're going to eliminate B because it says in the world. Okay, we know that this 12 represents noon. So it's definitely not midnight. It's definitely, so we can eliminate A. Okay, and then it says that the value represents the power used by all electric consumers in this city at noon, because that's what it is, at noon or before noon. And it's not before noon, it is at noon, so we're going to represent D. So there's the answer, D. Now let's take a look at F. It says, during what time interval did electricity usage decrease? And note that the 15th hour is equivalent to 3 p.m. Okay, so what we need to do is we want to find out where it decreased. But remember, let's just go ahead and find out where it decreased and where it increased. Okay, so I'm going to go ahead and then I'm going to go ahead and clear some of these information here so we can have a clear state here. Okay, so what we're doing is we're trying to figure out where did it decrease. Okay, and then we also want to see where it's increased. Now remember that where it decreased, okay, you're starting from here and it's decreasing to this point here. Okay, so that means on the x-axis it decreased from 0 to here, which is from midnight. And then this represents 3 a.m. Okay, and then from here, okay, it's increasing from 3 a.m. all the way up to, in this case here, this is the 15th hour, which is 3 p.m. So it's increasing from 3 a.m. to 3 p.m. Okay, and then it's decreasing again. It is decreasing from this point all the way down to the 24th hour. So it's decreasing from 3 p.m. to the 24th hour. Okay, so let's go ahead and then write our answer. So again, it's decreasing from here, from midnight to 3 a.m. and then from 3 p.m. to the 24th hour. So let's go ahead and answer that question here. So it is decreasing, we said, from midnight to 3 p.m. and then from 3 p.m. to midnight. So it looks like the answer is going to be B. Let's check our answer, and then there is our result. And now it says, at what time interval did the electricity usage increase? Well, in this case here, we saw that it increased from where? It increased from 3 a.m. to 3 p.m. So it increased from, again, 3 a.m. to 3 p.m. That's D. Check our result, and there is our answer.